So here's an interesting problem that we need to figure out now. And if you watched the last video for exercise number 5, you'll be kind of prepared to succeed at this. If you didn't, I recommend you go back and you check it out, or at least hopefully you check out the answer that the book has for that problem if you haven't solved it yourself yet. But do try to solve it yourself first, obviously. This question here, question number 6, is asking us to write a program that asks the user for the number of sides, the length of the side, the color, and the fill color of a regular polygon. So we know that we can go back into the chapter to figure out all of these different turtle attributes that we can change. We can change the color of a turtle, we can change the fill color of a turtle, we can begin fills, we can end fills. So we need to do all of that in a program. And thankfully, because we solved this problem up here, we know that to create a regular polygon, you need to have a turtle move forward a determined number for the size of the sides, and then turn left or right, either way works, by 360 degrees divided by the number of sides. So let's write it all out. What do we need to do? To import turtle, right? To ask the user for the sides, the length, the color, and the fill color. And obviously we're not gonna sit here and we're not gonna write code that checks to make sure all those values that the user gives us are accurate. We're gonna just assume that they're gonna give us good values, right? So we're not gonna double check that. We're just gonna take it on faith for now. Because writing the code to check that is a little tough for you right now. So we're just going to take it on faith at the moment. And then we're going to create a turtle, set it to the correct side, the correct colors, because we need to fit both the color and the fill color. So set it to the correct colors, and we need to use a for loop to draw, not to drag, to draw a regular polygon of the given number of sides, given size. I'm going to say draw a filled regular polygon, just so that we know that we need to fill it in. Remember that. Let's start at the top here. Let's import turtle. Do the turtle stuff. Import turtle. We're going to go ahead and I'll just create the window already right off the bat here. We're going to get a screen for turtle. Set it equal to WN, which is what we use for window by convention. You don't have to use WN. You can call it whatever you want. You can say my cool turtle playground. That would be fine. But where we're going to avoid using ridiculous variable names like that, let's go with WN for window. So WN equals turtle.screen. That gets the window set up for us. Then we need to ask the user for size, length, color, and fill color. Of this polygon. Get sides equals int, because we want it as an integer, input, enter number of sides. Whoops. Go. Issue there with overzealous undoing of typing. So int of input of enter number of sides, length, I'm gonna call that SZ for size. You can do whatever you want. You can do length if you want, you can do side length. I by convention use size. I'll use length for you folks this time, because it is technically probably a better usage of a variable in this case. So we'll do that. Length, we want it also to be integer, because turtles draw in units and regular units, so we want it to be an integer so we don't have turtles trying to draw in fractions of a unit. That would probably throw an error, I imagine. So we won't even try it. Enter length of sides. And then what else do we need? We need the color. So our color needs to be color equals, and in this case, we don't need to cast it as an int. We can just keep it as a string, because when we set the turtle color down here, we'll do it with a string like this. So if the user gives us a string, we'll just go ahead and we can ask the user to be nice for us, and we can say enter line color all lowercase. I don't know if that makes a difference, but we'll ask the user to be nice for us and to put it lowercase for us just to be sure. And then we'll say fill color, and we'll ask them to enter the fill color all lowercase. Awesome. So there we go. There's our inputs. We got our variables. Let's create our turtle. So what we want to call our turtle. In this case, I'm going to call my turtle, we'll keep using Mikey. We'll give him a lot to work with here. So Mikey turtle underscore turtle to access the module, and then or under lowercase, not underscore, lowercase turtle to access the module, dot to get inside the module, and turtle uppercase with open and close parens to say get me the turtle object off of you turtle module and set it equal to Mikey. So give me a turtle from turtle named Mikey, and we can then make sure that we set up Mikey's color correctly. So Mikey's color needs to be set to color, which is going to be confusing for him. He's used to being orange, but we can just set him to color directly here. And we want to make sure that we set Mikey's fill color, which I believe is all lowercase like that. We'll check it in a second. The fill color. Alright, so let's save it. Let's run it and see if we broke something. Oops. We broke something. So we'll say number sides is 5. We'll say length of sides is 25. We'll say the line color should be blue, and the fill color should also be blue. And does that throw an error? Nope, so that is correct. I just wasn't sure if I wasn't sure if it was this or if it was this. And I didn't want to go back and look at the book because I'm lazy. But you should look back at the book or check the documentation on Python. You can go to the Python documentation website that's inside the chapter here, but you can always find it at docs.python.org. You can always find it there all the time, 100% of the time, to find appropriate Python. So anyway, that is fill color, all one word, and then set it equal to fill color with an underscore, because that's what we've called it up here, and that sets Mikey up for us. And then we need to use a for loop to draw a filled regular polygon of the given number of sides. So we need to go ahead and know how to do this already. We need for I is fine because we're just going to iterate through these numbers. For I in range, well, how many times do I want Mikey to draw? How many sides do I want him to draw? We can't just program it with a number like we did before. We need to actually do it programmatically. So we need to get that from the information we already pulled in. So what did we pull in? We have right here the number of sides. We asked the user for it, so let's use it as our range. So for I in range sides, we need to have him draw that polygon. And we did it up here already, so we already know what the formula is to do this. We need to have Mikey go forward. Well, before we did 100, but now we gave the user the choice. So we need to make sure that we use what the user told us to use. And it shouldn't make a difference to our polygon, as a regular polygon, as long as all the sides are the same length, and the angles are the same, it'll all turn out fine. So we need to have him go forward that much, and we need to have him go left. We need to have him turn left. We can do right as well, but we'll do right this time. We'll get crazy with it. We'll do right this time instead of left. We'll have Mikey turn right. And how far do we need to make him turn right? Well, before, if we wanted to draw a square, we did 360 divided by 4. And we got 4 from the number of sides that the square had. So in this case, we need to switch it out with sides. Alright, and give ourselves that empty string, or the empty line rather, at the end of our Python program, and run it. And into the number of sides. Let's say we want to draw a pentagon. Let's say the length of the sides are 25 units long. Let's go ahead and we'll make them orange, and we'll fill in that pentagon that we make with yellow to make a nice, beautiful pentagon. And it didn't fill it in. Why didn't it fill it in? Well, if you think back to the chapter, and you can go back and look at the chapter if you need to, we need to do something, right? In order to actually be able to fill that stuff in. So we need to, if you haven't looked back at the chapter, or you haven't actually made your way through the chapter, maybe it's been too long since you made your way through the chapter, go back and look at that summary of turtle methods to figure out how to fill in a polygon. Find it? Did you look? Go and look. Seriously, go and look. Take a look at the turtle methods. We listed out all the most useful ones there for you, so go check them out. You find it? Yeah? Yeah, so you know then that the answer is begin fill. So let's go ahead and we'll just tell Mikey to begin fill. And when he's done, we'll ask him to end fill. Alright, there we go. Make sure we call them, because they are methods, so we need to call them with the actual function call here at the end, the open and close parens. And alright, let's do it. So number sides 5, length of side 25. We'll make them orange. We'll make it yellow. And go. And it still didn't work. Huh. Well, now we've got a semantic error, because we wrote what we thought we told our program to do was to start filling it out, and then go forward, and then churn, and then end filling, right? When you're done, end filling. And then, but we wanted a yellow filled in polygon here. It didn't work. So why didn't it work? Think about it. Take a look at the code. Think about it. Okay, you figure it out? This is going to be a common mistake, and you may not have made this one because it's maybe obvious here, but I promise you at some point you will make the mistake of putting something inside your for loop that you didn't mean to put inside your for loop. In this case, we didn't want to put begin fill inside the for loop, because that means that every time Mikey goes to start drawing a side, every time he starts the for loop over again, he's going to begin filling all over again. But we only want him to begin filling once. Similarly, we don't want Mikey to end filling every time he draws a line, because that way he'll never actually fill in a polygon. He'll always try to fill in a straight line, which doesn't make any sense. We want him to only do it once. So we're going to bring it outside of that for loop as well. So we're going to have him begin filling, then draw the polygon, then fill it in. Alright, saving it, we're running it. We're going to do the pentagon. We're still leaving it at 25. We're going to make it orange. We're going to make it yellow. And there we go. An orange outlined pentagon with yellow on the inside. Let's go ahead and make it a little bit bigger. And we'll go ahead and we'll do a... let's stick with our pentagon. Let's say instead of 25, let's go ahead and do 75. That should make it pretty big. We'll still make him orange, and instead we'll give him a green fill, right? So he's orange on the outside, green on the inside, green mostly, but with a little bit of orange. And there we go, a perfect regular pentagon here to represent our turtle Mikey. And so we learned a couple good things here, right? We learned that we can generalize our polygon algorithm that we created up there. We made a polygon kind of formula in our head, and we're doing different versions of it in our head, and then we realized, oh, we can actually generalize that and make it interactive, give the user the option to choose the size, the side numbers, the colors, etc. And then we learned how to set those according to what the user chose, and then we realized that we need to fill it in, and when you're filling, you don't want to have your fills inside the for loop. Sometimes you want to, when you're doing a for loop, have something that happens at the start of it, and then have something that happens at the end of it, but doesn't get repeated every time. And so to do that, you need to make sure you pull those outside your for loop, and when you're done, you end up with something beautiful like this. So I hope you got it. Hope that worked out well for you. I'll see you in the next